Thank you. All right. So in today's hangout, now finally, we're we're talking about jigsaw puzzles. And what we're going to do is I'm going to demonstrate. Um, First of all, you'll be able to download the application that I'm showing right now, which is a complete jigsaw puzzle application, very basic, but still you can expand upon it. What you're looking at here is one piece of the template, which is actually still for sale, and I'll be taking it down shortly, but because you can now get this for free. But one piece of the pure Corona, doesn't use SSK. I wanted to give it to people as pure Corona for this hangout puzzle. And what you've got here basically is you've got the puzzle tray, which is where you'll assemble your puzzle, and your puzzle pieces, which is where they'll go here. So let me hide the screen because I got to see the code to do this. This sample comes in a single file, well, main Lua. It's about 500 lines of code long, and it's fully documented. I won't bother you with seeing all that quite yet. And it also comes with, where is it? It comes with a guide on how to produce jigsaw puzzles, which is what I'm going to show you today is like the most basic way to do this. And when you run it and it's fully configured, basically what it does is it produces a jigsaw puzzle with 4 pieces, which you can pick up off the tray, drop onto the puzzle area, and when you get them close to where they're supposed to be, they snap into place. And when you get them all, you get a little notification that says the puzzle is solved. So before we look at how the jigsaw puzzle pieces are produced, let's talk about how the solved bit was detected. Basically, what you want to do, what I found the easiest way to do a jigsaw puzzle is to lay out the jigsaw puzzle when I'm creating the game. So the game is running, and the first thing it does is it lays out the pieces in the solved position. And it does this all in one frame so the user doesn't see it. And then what it does is each object, each display object, here's one display object, here's another one, and here's another one. You got 4 display objects. What we do is we save the solved position, so the X and Y position of this piece, right in the object. So I call it something like, let me look it up, solved X, let me make that good and big. Solved X is the current position of the object. Solved Y, current position of the object in the Y. And then what we do, so let me just step you through it here real quick without looking at all the code. Step 1, draw our puzzle area. Step 2, I draw a tray, someplace to place the puzzles before the puzzle is solved. Then place pieces. Places the puzzle pieces in their solved positions. And I should note that with 4 pieces, it's quite as simple as setting the anchor point for this piece to anchor X is 0, anchor Y is 0, and placing it in the upper left corner of the tray that we drew before that. Something you can simply say, give me the tray X and Y, and then subtract half the width, half the height, and you've got the first point to anchor that puzzle to or place it at. And then you place the second piece, and you make it anchor X equals 1, anchor Y equals 0, and then you calculate the upper left corner, upper right corner, and that's where you place the piece. Lower left is anchor X 0, anchor Y 1, and then lower right is anchor X 1, anchor Y 1. So you've got the starting position now, and then the next routine basically says it goes through the list of 4 and it moves them over to the tray. It shrinks them a little bit so they can fit, and it gives them a random rotation and just makes them look interesting. So at this point, you basically just grab it, and what that does is it zooms it back out to the normal size, re-rotates it, and then as you drag, it follows your finger, fairly closely. And if you get it close to the solved position, what's going to occur here is when I release my finger, a piece of code will execute. It's a touch listener. The ended phase occurs, and it says, okay, the ended phase occurred. Let's see our current position. And then we'll subtract the solved position, and we'll see how long of a distance there is between where I'm at and where I'm supposed to go when I'm solved. And if you're within a certain distance, let's just take a look at it real quickly. Let me find it, sorry.
And you can tell that the code is all well documented, so do go through and read the comments to see what's going on there.
Yeah, you're probably better off, actually. I just wanted to show it's too much for me to go through in the time we've got, but it's extremely easy once you read through it, and it's very thoroughly documented. Here it is. So on the ended phase, which means we lifted our finger, it does some of the normal stuff. It releases the focus, but then it says, okay, the dx dy, which is the difference in the x and y distances, is right here. So the current position minus the solved position, x and y. And then for people who don't know this, to get the length of dx dy, which is now a vector, you simply multiply dx by dx and dy by dy, add those together, and take the square roots, and that will give you the length of the vector. And I'm moving my hands like you can see me. And then, if that is less than some value that we've selected as an okay snapping distance, let's see what snap distance is. Snap distance is 15 pixels. So in other words, if this piece is less than 15 pixels away from the solved position, it will execute the next piece of code, which says, all right, close enough. Change the objects x and y to the solved x and y, and mark this piece as solved. It's in the right position. And then, once it's solved, you'll see in the listener that you're not allowed to drag it anymore. It notices that and says, oh, this piece is solved, you're not allowed to touch it. So very easy placement, pretty simple solution, but it's only for puzzle pieces, which is not very interesting to people. So I'm not going to drag you through how you make the puzzle pieces, because there's a complete document that comes with this that shows you every step. It tells you the software to use. The software you're going to want to use to do this for the example is Gimp, which is free. So if you don't have it, you can download it for free. There's a link right in here, somewhere in here in the document. Here it is. And it's very simple. It's just a few steps. There is a filter that comes with Gimp that literally produces jigsaw shapes. Now it's not very sophisticated. They all look fairly similar. You can't modify it. But having done this once with Gimp, then you can say, okay, good. I know how this works basically. Then you can go out and find a pay-for plugin for your art tool of choice, and there's many of them out there that produces varied and modifiable shapes of jigsaws. Or you can draw one if you wish, because drawing it or having it drawn for you, it's the same technique. The technique is, in a nutshell, produce your jigsaw shape. Let me find one. Sorry about that. Okay, so you produce this jigsaw shape. And then what you do is in your art program, you paste this over the top of a image that you want to convert into jigsaw pieces, and you simply select one segment of the jigsaw and you cut away the rest. And what you end up having, and this again is the simple technique of producing jigsaw pieces, what you end up having is a bunch of shapes like this that are all pre-cut jigsaw pieces. And this is a technique we're using here. Let me talk to the non-pre-cut technique. Interestingly, let me bring it up again here. It's actually in my...
So the fact that they're interlocked with each other is really the illusion.
Yeah, it's completely an illusion. This is one of the things that people stumble over, is they think there's some kind of like magic for detecting the edge here. Absolutely. If you had complete access to the OpenGL pipeline, maybe you could do that. But what we're talking about is cheating. Either you pre-calculate the position that this is supposed to go in, and then that's your solve position, or you do some fancy math subsequently to figure out what the solve position is. I prefer the cheating method, the solve it in advance and then just check to see if it's right afterwards. However, let me take you on a tour here of the other way to do this. Let me find it really fast. Where are you? Okay, so what if we wanted to do a 6-piece jigsaw puzzle? What I've found so far, and I'm not 100% sure this will work in all cases, is what you can do instead of pre-cutting your pieces is you can pre-cut the jigsaw into masks. So you produce a legal mask. By the definition, what Corona accepts is a mask. So this is a mask for the upper left piece, the upper middle piece, upper right, so on and so forth. And then, instead of cutting the piece, you simply display the entire image and you mask off the part you want to show. And then the interesting thing here is that the solved position for every piece is the same. It's the center of the piece. Let me show you this. Where are you? There it is. So that is what you're seeing here in this demo is the 6 pieces. I've masked off this part here, but in reality, this whole piece is the part I'm dragging around. But because of the way Corona works, is by default, the part that is translucent or transparent is not clickable. So when I click here, I'm clicking on the non-transparent part, the opaque part of this puzzle, not this one, and not this one. See, all these pieces are in fact overlapping, but we've cut out the visible, non-visible portions, and it's simple then. Easy to drag, easy to position. The only trick here, and this is sort of like an exercise for the listener, is you'll notice when I drag these pieces, well, in this case, not a problem because it's following my cursor exactly. I'm doing an offset calculation and moving it by the amount that I'm moving my cursor. But what if I wanted to automatically take this piece and move it over here and turn it a little bit and shrink it? Not simple, because what would happen is I'd be moving it by the center of the entire piece. I wish I could show you this example.
Yeah, because it's a big rectangle. So now now when it goes to shrink it, it's calculating based on the whole big rectangle.
The center. Exactly. Yeah. So what you need to do, here's the trick. If you want to use this technique, use this technique. Use the pre-mask, generate your masks, and then mask in real time the image that you want to make into your jigsaw puzzle. So make 6 instances of the image for a 6 puzzle piece. Use 6 masks, place them all at the same position, and this is the shape you get. Then, if you want to break the puzzle apart and put them in a tray or put them somewhere, what you need to do is say, okay, I got a 6 puzzle piece. Well, basically, I'm going to move this thing by the offset of 1/3 of the width, off from the center, and 1/3 up, off from the center. So it's a little bit of math. But just calculate a position that's here and then position it by that. The scaling is irrelevant. Well, that's not true either. There'll be a little thing that happens when you scale and you try to move. People will see it. When you scale, it changes the X and Y movement too. So I can't really describe it other than to say that you'll see something unexpected, but it has to do with the fact that you scaled it. And to fix it, just think, okay, if I scaled it down by half and I move it by 2, what does that do? Does that move it by 2? Does it move it by 4? What's going on there? The movement will be the same, but yeah, I'm not doing a good job. I wish I had finished this. Oh, well, actually, I take it back. This will be one of the things that I'll be selling as a module. So it'll be a prepackaged module. Just drop in your masks, tell it how many there are, and drop in your puzzle pieces, and then do the layout on your own. But it'll have little helpers to do the positioning.
So the thing that you were showing us before had when you had 4 pieces, that had sort of a prefab format to the pieces themselves, right? I mean, they're not special shapes. There's not like odd shapes.
Right. Yeah. These are like I said, these are the most rudimentary shapes, and they come out of Gimp. So it doesn't have a lot of options for making. The only 2 things you can do here, you can change the rows and columns in your jigsaw, and you can choose square pieces or rounded pieces. And basically, square or rounded pieces still have the same dimensions, but all they do is they put little curves.
Gotcha.
So, yeah.
So, but this would be a good starter for if you wanted to create a puzzle game, and it didn't need to be.
This is a good start to understand the principle of the shape and how you generate the shapes, because that's always going to be the same. That's not true. There is one other way to do this that we talked about. We being the folks here, we exchanged some emails prior to the show, and it was brought up that there is another way to do this. You can draw the shapes manually, or not manually, but in your code, and then mask them and create dynamic masks on the fly. Very advanced technique, not something I'm going to discuss, and probably not even something that I'm going to pursue. But if you want to pursue it, the starting point for learning how to do this is going and looking at the progress meter that we talked about several times now on the show. The circular progress meter does a dynamic mask of a circle. Same principle, different shape.
And we're talking about Jason's.
Yeah, exactly.
Okay.